So far we've been dealing with just atoms. Now we're going to do something similar, but now we're going to be dealing with molecules. So say we had the question, how many molecules in 444 grams of dinitrogen trioxide? The key thing is the chemical formula. The subscripts 2 and 3 tell us that we have 2 atoms of nitrogen and we have 3 atoms of oxygen in every molecule of dinitrogen trioxide. When we want to scale this up for molecules, we could use moles for molecules just like we used moles when we were talking about atoms. Remember, the unit mole could be for anything that you're counting. So we could have a mole of dinitrogen trioxide molecules. Instead of having 2 atoms only, this also gets scaled up. Instead of 2 atoms of nitrogen, we have 2 moles of nitrogen. And instead of 3 atoms, we have 3 moles of oxygen atoms. And what we can do with this is we can use the periodic table to tell us what is the mass of this mole of molecules in units of grams, because we know what the mass of 2 moles of nitrogen is. The periodic table value is 14.01 for 1 mole of nitrogen, so we're going to multiply by the fact that we have 2 of those moles. And then we're going to multiply the 3 by the value from the periodic table for oxygen, which is 16 grams. So when we total this out, we're going to get just over 76 grams. This is what's called the molar mass. And this is a key conversion that we're going to use quite a bit. N2O3, dinitrogen trioxide, has a molar mass of 76.02 grams. Notice that's grams per 1 mole, so this has 2 units. And remember, things with 2 units are a conversion factor. You can go back and forth. If you know the mass, you can figure out how many moles you have. So in this problem, we know we have 444 grams. So we can use that as our conversion factor. We want to know how many molecules of N2O3 there are in 444 grams. The calculation we just did lets us turn grams into moles. Every 1 mole weighs 76.02 grams for this particular chemical. And then once we have moles, we can use Avogadro's number to figure out the number of molecules. 1 mole of molecules, 6.022 times 10 to the 23rd. So our final answer is 3.52 times 10 to the 24th molecules.